Hey guys, Quiv the Lazy Geek here, and today we're going to talk about calibration frames and the type of frames in general. Because calibration frames are like, when you're starting off astrophotography, you'll be hearing things like light frames, dark frames, bias frames, flat frames, dark flat frames, flat dark frames, and then everyone's saying a lot of different things about those different types of frames, and it all gets very confusing very quickly. It does not need to be confusing, it's actually quite simple. Basically, a light frame is just an image that you take of your target. So if you're taking a galaxy in picture, it's any picture of that galaxy that you're taking. And you take typically many light frames, many lights, which each one is just a sub-exposure, also called as a sub or sub-exposure. You take many of them, maybe 30 seconds long, 1 minute long, 2 minute long, etc. It all depends on your setup. If you're interested in learning the details about that, I have a playlist about your exposure time or your optimal exposure time per subframe. Those are called lights. And those lights, they need to be calibrated. And why do they need to be calibrated? It's because they have what we call fixed pattern noise in them. And specifically your camera, my camera here, has a pattern that happens when you take a picture without any light hitting the sensor. And this is called like the dark current. And it's also mixed in with something else, which is called the read noise. And both have a specific pattern. And then you have something called dark frames, which contain both this dark current fixed pattern and this readout fixed pattern as well. If you're interested in knowing a bit more about those, you may want to watch my video on my series of videos on noise in astrophotography, which I'm linking to up there. And so you need to represent this pattern so that you can subtract it from your light frames, because your light frames include this pattern. And rather than keeping it in, you want to identify the pattern and just remove it from your light frame so you get better picture quality. As simple as that. And the advantage of dark frames is that they contain like all of the pattern for your exposure. So how do you take dark frames? Well, basically you want to take the pattern itself. Depends on the camera gain, or if you're using a DSLR DISO. It depends on the temperature of the sensor. It depends on the camera offset, if there's an offset setting you can play with, which is not the case in DSLRs usually. And it depends also on the exposure time itself. So the longer you expose, the more pronounced that fixed pattern noise tend to be. And so what you typically want to do is you want to calibrate your light frames with dark frames. So basically pictures that you take with the camera with the dust cover on, and make sure there's no light leak. So I prefer to take them at night without any light shining on my equipment, just to be sure. And you want to make sure that you take those dark frames. They should be the same length as your light frames. They should be the same temperature, they should be the same gain or ISO, and they should be the same offset. Now, if you have an astro camera that's cooled and you can actually set a temperature, it makes things very easy, because then you can take dark frames anytime you want, because you can match the temperature very easily, and matching the gain and the offsets, that's also super easy. It's just a setting in the software that you're using. And the exposure time, well, it's just the exposure time. You can match that very easily. If you're using a DSLR, you have two problems. One, you cannot cool your camera. Even if you can cool it, typically there's no set temperature to which you can cool it. And two, the camera reported by the camera, the temperature reported by the camera in the file properties that it saves is actually not the temperature of the sensor. It's very approximate, so it's very difficult to actually match your dark frames to your light frames, which means that for DSLRs, many people, they take dark frames right after they have taken their light frames, which can be, it's a waste of time each time. So that's why I love cooled cameras, because you can specify the temperature you want to image in for both your light frames and your matching dark frames. It's very convenient. Okay, so that's for the dark frames. And then there's another type of frame, which is called the bias frame. You might remember for the dark frames, I said it contained two types of fixed pattern noise. It contains the dark current, and it contains the readout noise. or the read noise of the sensor. And the read noise of the sensor, there's another way you can measure it. It's using what is called a bias frame. And a bias frame, it's basically, you also close the shutter. It's exactly the same thing. You don't want any light to be hitting your camera sensor, but you are going to expose for as the shortest time possible for your camera, because you want basically to have no noise related to the circuitry of the camera or to the temperature of the sensor. You want to have just the noise that the camera has when it just reads out the picture. So you want to expose, ideally you don't even want to expose at all, you just want to read from the sensor. So you choose the shortest possible exposure time, and then you take that sub-exposure, and that's called a bias frame. Now, bias frames, you need them to be at the same gain, offset, and temperature as your light frames. So that's another thing to know about that. There is one advantage to using bias frames in addition to dark frames, besides the fact that you can take bias frames very quickly. It's to use a feature called dark frame optimization. Basically, your fixed pattern noise that's caused by the dark current or the thermal noise is linear. It increases linearly with time, or decreases as well linearly with time if you take shorter exposures. The problem is you can't just take a dark frame and then stretch it to like make it brighter and brighter. So you know, I could take a 5-minute dark frame and think, okay, I'm going to stretch it, I'm going to make it brighter so it matches a 15-minute dark frame. That way I don't have to take 15-minute dark frames for my 15 minutes light. I can take just 5-minute dark frames and let's stretch them to the level of the light. And yes, it is somewhat possible, but the problem is that, as I mentioned, the dark frames don't contain only the thermal noise pattern or the dark current pattern, they also contain the readout noise pattern. And so to be able to do that kind of optimization, or that stretching of the dark frames to basically emulate a length of exposure that was your light time exposure, well, you will need to subtract the bias. So you wouldn't want to take a lot of bias frames, you average them so you get something that's called a master bias, and then you're going to subtract it from each of your dark frames, and then once you've done that, the dark frame doesn't contain the readout pattern anymore. It will only contain the thermal noise or dark current pattern, and then you can actually stretch that and do that. So that's one of the advantages of using bias frame, is that you are able to take shorter dark frames along with a lot of bias frames and then stretch your dark frames to match the length of your light frames. And that works very well for CCD cameras. It's historically worked less well for CMOS cameras, because most CMOS cameras have amp glow, and amp glow is a pattern like a starburst pattern that you see on dark frames. Even though there is no light, you can see a weird shape on your dark frame, and that's called by what is called amp glow. It's basically the circuitry in your camera is heating up the sensor. I mean, I'm very much simplifying there, and causing a pattern to emerge on that sensor, which should not be, you know, part of the sensor dark frame. And you can actually see that in the light frames as well, which is why it's critical to take dark frames when you have amp glow, because you need to be able to remove that amp glow. So that's how also bias frames can be used. Then you have what is called the flat frames, and flat frames, I have an actual two good videos about flat frames, which I will be linking to the top of this video. And it's basically a way to represent any issues in your optical system. So if you have dust on your sensor or in one of the filters or on the glass in front of the sensor, then that will be, you'll have a little spot of dust on your light frames. You will have maybe like what we call dust motes, like round things, or maybe even donuts, depending on your type of telescope, that will be on your light frames. And they're very difficult to remove unless you take flat frames. And flat frames, if I had to take only one type of calibration frames, it would be flat frames. Always take flat frames. Also, additional information on the main importance of the calibration frames. I mentioned that for me, flat frames are the most important. And that is because this camera doesn't have amp glow. If your camera has amp glow, like the 183 or the 294 from ASI or the 1600, you absolutely need to have dark frames, because the amp glow will introduce a pattern in your light frames that you need to get rid of. And the only way to get rid of in a decent manner and in a very automated manner is just to use dark frames of the same length, same gain, same offset, and same temperature as your light frames. So that's why dark frames can still be extremely important, and I always take them even if I don't have amp glow. But if you have amp glow, you cannot skip your dark frames. Flat frames, they don't need to be at the same gain, temperature, or exposure time as the light frames. They're almost unrelated. Flat frames are a type of light frame. And basically, you're going to point your telescope to something very evenly illuminated, and there's tons of methods to do it. The method that I prefer is to use a specific flat panel, which is basically an LED panel where you can hopefully change the luminosity, the brightness of the panel. You can put it on your telescope and just take frames. And flat frames, they're again the type of light frame. And another method is you wrap a t-shirt around your telescope objective. You secure it with some elastic band or something like that, and you make sure there's no wrinkles in that in that t-shirt, white t-shirt. You point it to an evenly illuminated wall, or you point it to the sky when it's dawn, this kind of stuff, and you take your flat frames. Now for flat frames, there's tons of rules. They're fairly difficult to take, and that's why I have specific videos about that, which again, I'm linking to up there. And then, okay, I've mentioned that a flat frame is a type of light frame that will basically measure the characteristics of your system, also measure any dust motes, and you'll be able to remove the dust motes and the issues with your optics using those flat frames. You'll remove them from the light frames. The problem is, the flat frames, they're light frames as well, of a certain type. They're not light frames of your subject, they're light frames of your telescope optics, really. And so they also need to be calibrated. So you would typically want to have what we call dark flats or flat darks, depending on whoever you talk to. And you want to take dark frames for your flat frames. And your dark frames for your flat frames should be the same gain, offset, and exposure time and camera sensor temperature as your flat frames, just like your darks for your light frames. So that's another type of a calibration frame that you take. So we talked about dark frames, bias frames, flat frames, and dark flats or flat darks. So there's 4 main types of calibration frames. In those, I would say that for me, the most important is the flat frame. The second most important will be the dark frames, both normal dark and flat dark frames. Those are quite important. They remove the pattern noise. And for me, the least important, and I actually don't bother with it, is bias frames. And the reason is that the bias frames contains the read noise, the image of the fixed pattern noise that comes from reading from the sensor. But the dark frames also contain that. So the advantage of taking bias frames is that you can take many, because it's a very short exposure. It's even the shortest exposure time that you can manage. The disadvantage is that on some cameras, especially CMOS cameras, the answer from the camera for very short exposures might not be always consistent. And so that makes bias frames unreliable. And for most CMOS cameras like this one, I have decided not to take bias frames, and because it's a cooled camera and I can take dark frames anytime I want, I can take dark frames, during the day, during the night, whenever it's cloudy. I can take as many as I want, and so there's no advantage to me to take bias frames, because the dark frame, as I mentioned, contains both the readout noise and the dark current or thermal noise. So it's kind of a super frame that contains the bias as well. So in practical terms from me, I do not take bias frames, and that makes my workflow easier. So why not? Oh yes, quiz from the future here, even more future quiz than the previous quiz from the future, to talk a bit more about those dark flats or flat darks. And flat darks for me, they work well, and one of the reasons is that I take my flat frames with a flat panel and I keep the exposure of my flat frames between roughly 1 and 3 seconds, or maybe 2, 3, 4 seconds, that kind of interval. But for some people who use other techniques like sky flats, where you use the sky plus a t-shirt on top of the telescope to actually take your flat frames, you might end up with much lower exposures. And some of the CMOS cameras have trouble taking calibration frames at very, very low exposure times, in which case you might be better off taking a bias frame. But wait, a bias frame, my past self just explained that it's a frame that ideally would be 0 seconds long. Yes, but again, because of the specificities or the idiosyncrasies of the sensors themselves, the minimum time that you can, exposure time that you can use for calibration frame might be different depending on the sensor. So I've heard that, for example, for the 1600 mm, many people use 0.1 second for bias frames, and they use those bias frames to calibrate their flat frames rather than flat darks, because flat darks for them cause issues, and I believe it's probably because their flats are very short. And for the ASI 294 and other cameras based on the same sensor, people will take bias frames of 1 second long and will avoid flat darks because those flat darks are too short for the the flat frame calibration. So it all gets a bit complicated. If you have a flat panel, you can just choose the proper exposure lengths for your flats to be a couple of seconds long, and then you're fine to use flat darks. If you have very, very short flat frames, then you may want to use those modified bias frames, which have a decent exposure time, and it will work better in that case. So it really gets weird and a bit complicated when you're having very, very short exposures on some of those CMOS sensors, but not all. Typically, if you have a sensor like that does not have M-glow, you can use flat darks or you can use bias frames, as long as your flats and flat darks are long enough. If you have a sensor with M-glow, then ideally you should use flat darks instead of bias frames for calibration of your flats. The point being that there's not so much thermal noise or dark current noise in a frame that was taken for just like a couple of seconds, right? So you can basically approximate a 1 second or a 0.1 second exposure time as a bias frame. And that's what is happening with those kind of calibrations of flat frames using a 0.1 second or 1 second long bias frame. It's not the end of the world. So there are little like differences, and so when you're first using your equipment, this is something that you'll need to figure out, and it's not super easy to do. But once you figure it out, you just follow the process over and over and over again, and that's fine. And what I'm showing in this video is my process with the assumption that your flats, you can control how long the exposure time for them will be. And that's why for me flat darks will work. Now also quiz from the past will also explain how to take bias frames in Nina, and for that quiz from the past we'll be using very, very short exposures like 0.01 seconds, and again that might work for an ideal camera and an ideal sensor, but for a lot of CMOS sensors that's an issue, and so you would take longer bias frames as an approximation for a shorter bias frame, like 0.1 second for the 1600 mm or 1 second for the 294. I don't know about the 183, I don't know about the 533, which I own because I don't take bias frames with it, but this is something that kind of needs to be researched by each user if you're going to use different techniques of flat frames like t-shirt or sky flats, which is why I really recommend, if you want to be lazy, to just use to just make the investment for a brightness adjustable flat panel, and then everything suddenly becomes more simple. Anyway, that's pretty much it from quiz from the future here, so I'll give it back to quiz from the past. See ya! Okay, so now we understand what those calibration frames are. Now, one of the questions that often comes is, how many dark frames should I take? How many flat frames should I take? How many flat dark frames should I take? And how many bias frames should I take? The answer for all of them except flats is as many as you can. So flat frames, they'll typically be short. I tend to like them between 1 and 3 seconds in length. It depends on people. Again, I have videos on that which I've linked to before. I'm linking to again because it's quite important. So I will tend personally to take 25 flat frames, and it's very easy to take 25 flat frames, especially if you have an illuminated flat panel like I do. And then for both dark frames and flat dark frames, I try to take at least 50 of each if I can. If I cannot, well, as many as I can. The reason is that your dark frames, they try to basically approximate this fixed pattern noise that I mentioned. But this fixed pattern noise has a random element to it. So each dark frame that you take will have a small difference in terms of this fixed pattern noise, which means the fewer dark frames I take, the less of a reliable image I have of this fixed pattern noise that I want to remove from my light frames. So as many as possible is always good, and that's why it's always nice to just be able to take dark frames whenever you want to. And dark frames, most people, they take one set of dark frames at a given temperature, the temperature they're going to use and the exposure time they're going to use and the gain and offset that they know they're going to use, and they keep those for like 6 months, and after 6 months they renew them. So that's what's very convenient for dark frames, both for normal darks and flat darks. And then there are the flat frames. The flat frames, you will need to retake them anytime there is a change in your equipment. If your camera here is rotated, that's one change. You need to retake your dark frames, your flat frames, sorry. If I change the filter here, then you need to retake your flat frames. So if you have a filter wheel with multiple filters, you'll typically want to take one flat frame per filter. So that's one thing to keep in mind as well. But as long as I'm keeping this assembled, I will not need to retake flat frames. So this is how it all works. So now let's have a look at how I can take dark frames for my camera that's currently attached. So you can see that I'm using a free and open source software called Nina. That can control your camera, your telescope, your filter wheel, your flat panel, all sorts of stuff. And it lets you do sequencing and take light frames, dark frames, bias frames, flat frames, and flat dark frames. It also has, by the way, a flat wizard to automatically take flat frames and their matching flat darks, which I've covered in another video, which I'm pointing to upstairs. So many videos that you can consult on that. It's a big rabbit hole. But let's say I want to take dark frames. So what I would do is I would make sure that I'm at the temperature that I am usually imaging at for this camera. So if it's a good camera for which you can change the temperature. If you cannot control the temperature, well, you need to take your dark frames right at the end of your session to be sure that they have roughly the same temperature as your light frames. And same for the dark flats versus the flat frames. For me, I can choose my temperature, so I've chosen it to 5 degrees, and you can see my chip temperature is at -5 degrees, exactly as I intend. I also want to take the same gain and offset as my light frames, and this is my usual offset. For CCD cameras, you typically don't have access to those parameters, so you don't need to care. For DSLR cameras, it would be the ISO. Then I will just go into my sequence and say that I will want to take dark frames, and I want to say, like, I want to take them. I need to choose the length, and for me, my light frames are 30 seconds long, so I'm going to take 30-second dark frames, and I could say that I'm going to take 50 of them, right, to have enough. And I can choose a filter. You don't have to choose a filter really, because anyway, there's no light that comes to the sensor. That's the purpose of dark frames. I don't need to dither, I don't need to do anything, and that would be my dark frames. And the next ones would be my flat darks. That's the type I like to take. So dark flats here, okay? And same thing, I want to take the same length as my flat frames. The last flat frames I took were 1.5 seconds long. I took them at the same gain and offset as my light frames, so I do not need to change anything. So I do not need to like set a specific gain and offset for my dark versus dark flat in my particular case. If you took different gain and offset, then you will need to change that here. And there's some cameras, by the way, that don't like low gains, like the ASI 294 MC Pro doesn't like low gains. You typically want to be above or at 120 with this camera. If you're not sure what gain or offset to use, by the way, I have a video on that as well, and I'm linking it at the top. Again, the rabbit hole as usual. And okay, so I have my dark frames, my dark flats. I've taken my flats separately, and as I've mentioned, I don't like to take bias frames, so I don't take them, and I just take enough dark and dark flats so that I don't need those bias frames. And then I'll just, click the start button, and it will start exposing. And yes, there it is, and we're exposing, and I just need to wait for my frames to come in. And this is how you take dark frames and flat frames and dark flat frames, and maybe even bias frames. Of course, it can work with any other piece of software. So, don't fret about it. SGP will work, APT will work, Nebulosity will do that, Backyard EOS or Nikon, Backyard Nikon will also do that. So you just need to take your darks and your flat darks and your flat frames, and if you're really feeling like it, your bias frames, although I tend not to. One of the questions, by the way, that comes again, like, shouldn't your dark frames or number of dark frames or number of dark flats be related to number of lights or number of flats? And the answer is no. I've already alluded to that in this video. You just want to take as many dark frames or as many flat darks as you can, and that's pretty much it. So that was it. That was, a pretty long video to explain a concept that's actually in the end quite simple, but it tends to confuse a lot of beginners, myself included at the time. So I hope this was very useful. And if you like this video, if it was useful, please click like. Please also subscribe and click on the notification icon. I'm planning to shoot another video about how to actually apply your dark frames, flat frames, dark flats, and bias frames to your light frames as necessary, using Deep Sky Stacker and also PixInsight. So make sure you subscribe so you don't miss this. And as always, don't forget to look up at the stars. It's a bit cloudy, but I can see the moon there, so that's good. I'm gonna have a look at it with my telescope after that. And anyway, I hope you enjoy this, and I'll see you next time.